Alrighty. Well, in this particular lesson, we are going to write and interpret numerical expressions and compare expressions using a visual model. So this is really just kind of like those story problems, only like abbreviated, little bitty. So they're not going to be huge. And so my first one that I'm going to give you is like 3. Oh, why are you not writing right? 3 times the sum of 26 and 4. Okay, well, what this says to do, if I look at it carefully and I go in order, is 3 times the sum of 26 and 4. So I see 26 plus 4. And I went ahead and put that in parentheses just to know like that I was going to add those first because I'm going to do 3 times the sum. And so the total of those two. So I'm going to add these two first. I get 30. And then I'm going to get 3 times 30. And again, if I know my basic facts, this becomes a lot easier, right? Because 3 times 3 is 9. And then I have 1 0. So I'm going to add that 0 on back. So I get 90. 3 times the sum of 26. So it's just thinking that through and thinking through what they're actually saying. And I like to kind of go in essentially the order that they're saying the problem. So let's try another one, okay, and see how we do with it. So let's see if we can do 6 times the difference. Okay, what does difference mean? This is one of those words that has different meanings depending on its context, right? In reading, it's like compare and contrast. What's the difference in these two things? And in math, it means to subtract. So we need to remember that that means subtraction. 60 and 51. Okay, so again, 6 times the difference between 60 and 51. So 6 times, multiply, the difference between 60 and 51. So it's 6 times the difference of 60 and 51. So this is what that equation actually says. Because here I have 60 take away 51. That's going to give me the difference there. So 60 take away 51 is 9. And then 6 times 9. So I'm just doing 6 times 9, which is 54. So again, just anytime I know my basic facts, I can cruise through things a little bit faster, okay? Just lets me figure out what I'm doing quickly and efficiently. And being quick and efficient is really important in math. Okay, well, I'm going to clear all of this out. We'll try another one. Oops, I moved my little face. Not what I wanted to do. Clear. Erase. Go away. It's not erasing, y'all. I don't know why. There we go. Okay. I switched to the like teeny tiny eraser, and all of a sudden magically it was going to erase, but the big eraser wasn't going to. I don't know. It's neither here nor there. Okay, so we can think about different expressions and how they describe value and total value. So if we did like 3 times 5, right, we could think about, well, a number strip, right, and 3 5s. So we have 5 here, and 5 here, and 5 here, which is 15, right? And those could be considered addition. So they're 3 equal units. And so this is a tape diagram. So if you get asked to do a tape diagram, this would essentially be what a tape diagram is. Or 3 times the sum of the one that we did earlier, 3 times the sum of, separate this into 3s. This is the sum of 26 and 4, right, which we know is 30. So 3 times the sum of 30. That's just another way to show or model that is with that tape diagram and then making those equal parts. So on this lesson, it will ask you to be able to model utilizing that tape diagram. So I want to show you another problem utilizing this, and I'm going to just bump myself forward. That's old work. Okay, so one of the things that we can do is, let's say we have 2 copies of 12 plus, so 2 times 12, 4 copies of 3, right? We can show this on a tape diagram by going, hey, this is 12. Here's 12, and I know those aren't quite equal, but imagine that they were. I didn't draw them perfectly. And then 3, 3, 3, and 3. So this would be a picture representation of this. If you were asked to give a picture representation, right, this is the 4 times 3, this is the 2 times 12, right? I can figure these out really quickly. 2 times 12 is 24, 4 times 3 is 12. Ultimately, I have 3 times 12 is what we kind of have here, right? So 3 times 12 is 36. And we have that modeled here if you needed to do repeated addition or add those up, okay? We can also take things and we can convert them from a numerical expression into a word sentence. So for example, if you saw this equation, what you could say is 8 times the difference, right? Because difference is our subtraction word. Difference of 43 and 13. And I could write those out as words if I needed to, but this pretty much gets me there, right? This is what those words mean, or what those numbers mean. Let's take a look at another one. Go ahead and bop myself forward on the board here. So if you had this number expression, there's multiple ways we could think about this, and we could say the sum of 16 and 9 times 4, or multiplied by 4, or 4 times, I could say this the other way around, 4 times the sum of 16 and 9. So there's multiple ways to write things. You'll see that as you get going on this and get into it, that there's different ways that we can kind of think through these and write them out. I often, when I'm going from word form to number sentence like up above, I often just do it in the correct order that it is. So you're going to be doing this tape form, solving some problems and converting them from both the number sentence into word form, or from word form into number sentence, and thinking that through. So you'll be doing a lot in this particular lesson and showing the differences between those different ways to solve equations using multiplication.